A pleasant welcome. Today we're going to be looking at the Math 2017 June solutions to our multiple choice paper, and the focus will be on geometry and trigonometry questions 53 to 60. I'm Teacher Walton. The word of God in Matthew 5:6 says, "Blessed are they which do hunger and thirst after righteousness, for they shall be filled." Now this is being brought to you courtesy the Math Ministry, and let us begin with question 53. So question 53 gives us a pair of lines intersecting, and this first line here is PR, and the other line here is AC. Now we are told that they intersect at the point B, and this angle here is 58 degrees. Right, so let's read the question. They want us to find angle ABE. Alright, let's see if there's a E. Okay, so this should be the point E right here. So let's fix that. ABE. ABE. So they want us to find this angle here, theta. Right, so angle ABE. Now we know that the sum, this is a straight line right here. So therefore the sum of 58 and angle ABE represented by theta would be 180. So therefore ABE would be 180 minus 58 degrees. And this will give us an answer of 122 degrees. Right, so the choice there would be answer B. Let's move on to question number 54. Right, so again 54 is testing our understanding of isosceles triangles. Now do you remember that an isosceles triangle looks something like this? But in an isosceles triangle, these two sides are of the same length, and these two angles here are also equal. So let us go back to the question. They tell us that this angle here is angle X degrees, and they give us one angle here as 30 degrees. So you have guessed it, they ask us to find the size of angle X. So if that is 30 degrees at the base, then this angle here is also 30 degrees. Now the sum of the angles in a triangle add up to 180. So it means that X degrees plus 30 and 30 is 60 degrees equals 180 degrees. So therefore if we are solving for X, X will be 180 minus 60. So therefore X will be 120 degrees. And that will correspond to answer C. Right, so that's question 54. Let us go on to question 55. Right, in question 55, we are given the line y equal to x. Now the line y equal to x passes through, as shown on the graph, on the diagram, it passes through the origin. So that's our origin here. It passes through the origin. And this is y equals to x. So the question tells us what is the image of the line y equal to x when it is rotated anti-clockwise about O through an angle of 90 degrees. Okay, so in this question we need to identify a couple things. So we'll take a red marker. When the line is rotated anti-clockwise, which is in this direction, anti-clockwise, the new line will cut this line at 90, approximately like that. Right, so that too will pass through the origin, and this angle is 90. So they basically want us to find the image, which is the equation for this line. Now, we can make use of our coordinate geometry. The line in blue, which is y equal to x, and the red line, they are perpendicular. So it means that the product of their gradients would be -1. So let's call the gradient of the blue line MB and the gradient of the red line MR. When you multiply those two gradients, the product is -1. Now, the gradient of the blue line here is 1. So 1 by this gradient MR will equal -1. So it means that MR, the gradient of the red line, will be equal to -1 because 1 by -1 equals -1. So we know that this gradient MR equals -1. What else do we need to find the equation of a line? Well, the equation of a line can be written in the form y equals to mx plus c. Now c is the y-intercept where the line cuts the y-axis. Now looking at the red line, it cuts the y-axis at 0. So if your gradient is -1 and it cuts at 0, then the equation of this line will be y equals to -1x, or simply y equals to -x. So let's see which answer gives us this choice, and that will be your answer for this problem. Okay, so that will correspond to answer D. So let us make sure that was question number 55. Let's put in our numbering of the question here. If we have not done that already, there it is, question 55, right? So we move now to question 56. Right, in question 56, you are given two similar triangles. So let us attempt to draw these triangles here. You have one triangle looking like this. That's the bigger one. Right, let's bring down the line here. Supposed to be right angle triangles. Right, we are given this angle here as 59 degrees. Let's put it in 59 degrees. We are given this angle here as 31 degrees. We are given the length of this side as 7 centimeters. And we have a corresponding triangle which is similar to the one that we have there. So that's it. So this triangle is MON, and this triangle is ABC. Right, this angle here is also 59 degrees because it is similar to the one drawn ABC, and this angle here is also 31 degrees. So the question says, what is the length MO? Now, they also give us some additional information. The length here is 6 centimeter and this one is 3 centimeter. So the first thing we need to find is the factor. We call it the scale factor. We know we are moving from big to small, so therefore what's happening here is not an enlargement, it is a reduction. And this reduction is with scale factor. Let's see how many times it is reduced. If we look at the two sides here, the smaller triangle is 3 centimeter for MN, corresponding to the similar one across here AB is 6 centimeters, so your scale factor is a half. Right, so let's recap that. The first thing we need to determine is the fact that it is a reduction. It is being reduced as we move from triangle ABC to triangle MON. The second point is we need to determine what is the scale factor. So the scale factor here tells us the number of times that this is reduced. And the scale factor here, you put in 3 over 6, so it is a scale factor of a half. Now, if we need to find the corresponding side on the smaller triangle to AC, that will be MO. So this 7 centimeters will also be reduced by the scale factor of 1 over 2. So therefore, MO will be half of 7 centimeter. Notice we are using the scale factor of a half, multiplying it by the length AC to find the length MO, and that will be 3.5 centimeters. And that corresponds to answer C. Right, so we are now on question 57. Right, number 57. What's 57 is about? Let's see. Okay, in this question, number 57, again, you are being given a right angle triangle here. Right, we're given a right angle triangle here. And this triangle is ABC. Right, we are told that AB is 40 meters. And this angle here is 30 degrees. And we are asked to find the length BC. That is this side here. So let's see what we are given. We are given the opposite. This is the side opposite to the angle 30 degrees. And we are given the hypotenuse. So there's a trigonometric ratio, which is the sine ratio that connects opposite with hypotenuse. So sine A would be the opposite. We need to find that, and that is the length BC divided by the hypotenuse, which is 40 meters. So if we cross multiply here now, if we cross multiply, we arrive at the length BC is equal to 40 sine A. And of course, we know the angle here is 30 degrees. So this will be 40 sine 30 degrees. Now we're going to recap this. This corresponds to answer A. Let's make sure that we did this sum correctly. So we have our triangle ABC. The length BC in meters is, right, they give us the length AB as 40, the angle A as 30 degrees. The only ratio that connects opposite with your hypotenuse is the sine ratio. So you say sine A is BC, which is the unknown, divided by 40 degrees. Right. Let's expand a bit. Nice. So when we do that, when we cross multiply, we get BC by 1, which is BC, is equal to 40 by sine A. Now angle A is 30 degrees, so the answer is 40 sine 30. Okay, we go on to question number 58. Let's proceed to 58. Right, number 58. Right, in question 58, you are given a right angle triangle again. So you see how popular this right angle triangle is in these questions. Right, so you're given a right angle triangle. Oh, this one is being drawn terribly. Let's remove that line. Right, let's pull this line somewhere like this across here. Right, that's much better. So this is your 90 degrees here. And this will be angle ABC again. A, B, and C. Right, this length is 17 centimeters. This one is 15 centimeters. And we are asked to find the missing side, which is x centimeters, labeled as x centimeters, as the side BC. Now, we need to look at Pythagoras' theorem. Pythagoras' theorem says that the hypotenuse square, the longest side, which is AB square, would be the square of the sum of the two sides. Right, let's repeat that. The hypotenuse square will be the squares of the two sides and you add them together. So let's go. It will be like AC square plus BC square. So it is the square of the sum, right? The squares, or the sum of the squares rather. The sum of the squares of the two sides. So what do we know? We know AB is 17, so that'll be 17 square. Will be AC square, which is 15 square. And we need to find out BC. So that BC square. Now let's work out this quickly. 17 by 17. 1 by 7 is 7. 7 sevens are 49. 7 ones are 7 and 4, 11. So 17 square is 289. That goes right here. And that will equal 15 square. Let's work out 15 square. 15 square is 15 by 15. 1 5 is 5. 1 ones are 1. 5 5s are 25. 5 ones are 5 and 2 7. So this will give us 225. So this will be 225 plus BC square. So 289 minus 225 would equal to BC square. So let's do the subtraction. Across here, 289 minus 225. That gives us 64. So 64 will be BC square. So therefore BC will be the square root of 64. And we know that will be 8. So BC will be a length of 8 centimeters. Okay, so that'll correspond to, that's number 58. That'll give us an answer of B. Right, so we have two more questions to go. Question 59 and question 60. Right, so in question 59, you are told that in triangle PQR, so let's draw a triangle PQR. Right, PQR. Angle P is X. So let's put in angle P up here. Angle P is X. We are also told that angle Q, alright, let's put Q down here. Now it's not drawn to scale. We are told that angle Q is 2x degrees, right? And they want us to find the size of angle R in terms of x. So we need to find what is angle R. Now we know that angle R plus angle P plus angle Q is equal to 180 degrees. So angle R, let's put in the values now for angle P, which is x degrees. Angle Q is 2x degrees. And this will equal 180 degrees. Angle R plus 3x degrees is 180. So angle R will be 180 degrees minus 3x degrees. Right, and that is your answer, answer D. Lovely, and then we move on to our last question, question number 60. Right, so they always end with a bang. So question 60 is dealing with your angle of elevation and so on. So they give us, and I'm going to draw this diagram for you here. They give us a door. Or it could be the height of a building. It looks like a door. Alright, so then you have a surveyor. Let's put the surveyor right here. The surveyor is doing his thing, standing on ground level, right? He's right here on the ground. And he is surveying using his instruments. He's using his instrument, a tripod stand. It looks like a tripod stand. And he is doing some surveying. He's trying to determine the height of this building. So he looks up here from his instrument and he gets the angle of elevation as 40 degrees. Right, we are also told that the height of this man is 1.6 meters. So this distance from here to the ground is 1.6. Of course, it also corresponds to the distance or that part of the building, which is 1.6 on this side meters. So we need to determine the height of the building. We are also told that he's standing 12 meters away from the building. Now, in order to determine the size of the building, we need to consider the main triangle, which is this triangle here. The main triangle is to the surveyor's eye or his instruments coming across here and going back up here. So let us label that. We're going to call this triangle A, B, C. So we need to find the length AC. Once we have the length AC, we can always add it to 1.6 meters and get the height of the building, which will be the total height from here all the way down to here, the height of the building. Right, so let's see what is involved here. We know in this triangle, this is 12 meters, this length BC is 12, it's adjacent to the angle, and we need the opposite. So the trigonometric ratio that connects opposite, side opposite, with the adjacent to the angle is your tan ratio. So you have tan 40 degrees is equal to adjacent, no opposite, sorry, side opposite over side adjacent. So let's substitute. Tan 40 is equal to side opposite, which is AC, we need to find that, divided by the adjacent, which is 12. Again, if we cross multiply, we're going to get AC is equal to 12 tan 40 degrees. Right, so let us see how we can determine the total height. So the total height of the building will be AC, which is 12 tan 40, right, tan 40 degrees plus the 1.6 meters, right, and that is given as answer D. So that will bring us to the end of this session where we looked at the solutions to our geometry and trigonometry questions for Paper 1, June 2017. Remember the word of God? He says to continue to thirst and hunger after righteousness. May God continue to bless you.